So we're going to get started with our second session of talks. Thanks to all of our speakers in the morning session. It was really interesting to hear not just about all of the cool technical work that everyone's doing, but also everyone's unique path through their journey through their STEM degree and through SMART, and then eventually employment with the DoD, and to kind of see the influence that the SMART program had in shaping their work, whether within academia while pursuing their degree, and then eventually that transition and how easy that transition was to become an employee. So we're going to keep going with our second set of talks. To MC this round, we have Ms. Monica Soriano. She's the Naval Component Liaison, and she'll be introducing our first speaker. Monica, over to you.
Hi, thank you, Dr. Kokenhauer. Good afternoon, everybody. Hello, my name is Monica. I am the SMART Naval Component Liaison, and I'm really excited to introduce the next round of Symposium technical talks that we'll be going over in this afternoon session. The afternoon session will be focused on test, evaluation, and applied engineering. We have 4 presentations for you in the session, so it should take about an hour. And any questions that you do have for the presenters, please go ahead and put them in the chat. And if time permits, at the end of each presentation, we will pose those questions to the presenter. I also just wanted to note that Miss Alexis has been kind enough to offer to help me monitor the chat, so she will help field any of those questions. And any questions that we aren't able to get to in this session can be moved to the Whova app on the community board, and we can certainly get to them that way. All right, let's go ahead and get started with our first presenter. Okay, so our first presenter is Brian Sinkovic. He is at Arnold Engineering Development Complex, and his project is titled Dinos and Rocket Sleds, a Smart Way to Conduct Test and Evaluation. Go ahead, Brian.
All right, I'm going to try to share my screen here. And let me know if and when you can see that.
Yes, we can see it.
All right, great. All right, well, thanks for the intro. So yeah, welcome. So again, my name is Brian Sinkovic, and I'm a SMART alumni from 2014, 2015. My topic is, it's called Dinos and Rocket Sleds, a Smart Way to Conduct Test and Evaluation. I had to try to come up with an interesting, creative name to keep you all, kind of keep you guys on your toes here. I'm coming to you from the Arnold Engineering Development Complex, or AEDC, as an engineer actually located at Holloman Air Force Base in New Mexico. And we had a lot of really good presentations this morning, highly technical, lots of doctors in there. I'm not going to try to speak that language, but I'm going to keep it more top level, a little bit more programmatic, hopefully no less interesting though. All right, so my current facility is, too many. My current facility is and position is at AEDC in the Test Capabilities Integration Branch at Holloman Air Force Base, where we are an operating location separated from our parent organization for the most of the rest of AEDC, which is at Arnold Air Force Base in Tennessee. Our particular operating branch is a small group of just 4 individuals within the Plans and Programs Office within XP, and we provide strategic engineering and long-term capability development that identifies future requirements for ground testing at specifically at the 704th Test Group, which is within AEDC, but it's actually headquartered at Holloman Air Force Base, and thus is the reason why my group is located there, working on behalf of them mostly all the time. We do a lot of technical capability development, but also advocate for adequate funding through various means to ensure that we're going to bring ground testing specifically through our capabilities up to the means necessary now and in the future. So ground testing offers a controlled environment, typically at a relatively low cost and risk compared to flight testing to evaluate system or component performance and readiness before fielding. AEDC is one of the DoD's premier organizations with many world unique capabilities for testing weapons, equipment, really a lot of things, typically in the developmental testing world, embedded in a program years before actual fielding. But we have also done testing, to support rapidly fielded capabilities, such as certain items on aircraft ejection seats that have to be fielded within weeks or months. A lot of those have to get qualified, say at the Holloman High-Speed Test Track, which I'll talk about here in a slide or two, about getting that equipment out into the warfighter so that they can use it pretty rapidly. So the 704th Test Group in particular conducts world-class T&E in important areas such as weapons lethality, as I said, egress, aerodynamics, survivability and landing gear, guidance, radars, directed energy, all the like. Okay, next slide. As mentioned, within my particular organization, we advocate for and manage projects on behalf of the 704th Test Group, of which there are really 6 distinct capabilities, or squadrons / individual organizations. Since there's only the 4 of us in my unit, and one of them is a supervisor over everything, the other 3 of us really support mainly 2 capabilities each. So my capabilities of focus are first the aerospace vehicle, Aerospace Survivability and Safety T&E Office, or OLAC in Ohio. It's at Wright-Patterson Air Force Base up there. This one is made up of 2 different capabilities, actually. It's the Landing Gear Test Facility, or LGTF. So at that facility, we test aircraft tires, wheels, brakes, systems, really, et cetera. It does asymmetric wear testing, drop testing, high load and shimmy testing. Really a world-class facility there up at Wright-Pat, testing through DoD, other government agencies and commercial agencies to come to us for independent T&E, specifically on landing gear. Also at OLAC is the Aerospace Vehicle Survivability Facility, or AVSF. That is a facility where we test integrity to aircraft bodies, fuselages, fuel tanks, many different things against potential threats. And actually, my first DoD job, placed through the SMART program back in 2015 and 2016, was at the Landing Gear Test Facility. And then my second capability that I oversee and support is the Holloman High-Speed Test Track, which is in southern New Mexico at Holloman Air Force Base, where we test a multitude of different weapons and equipment, from ultra-high-speed lethality testing to impact penetrators, bunker busters, material characterization through weather erosion testing. We've supported, pretty fast customers here. I guess also dynamic ejection seat testing. It's the longest and straightest sled track in the world, so we're able to do speeds from real low speed, subsonic, like in egress testing, all the way up to ultra high speed lethality testing. We actually have the Guinness World Record land speed record at 6,453 miles an hour. We were able to propel that sled there that you can see on the left side of the screen, lower left there, up to what that equivalent is, about Mach 8.4, so almost 8.5 times the speed of sound. So after the landing gear and going off to get my master's degree, I worked at the track from 2017 to 2020 before moving into my current role. So it's pretty cool to be able to see, these 2 organizations I've previously worked for, to work with them a lot now in my current position. And I think a lot of people, understand pretty easily what the landing gear test facility would do. Everybody knows landing gear on aircraft. To get a better sense for the Holloman High-Speed Test Track, I wish I could show you guys some videos on here, but don't really have the time for that. But if you you can just go into YouTube and search the Holloman High-Speed Test Track. You're going to get a lot of really cool videos of some of our dynamic testing. And really, I guess a pop culture reference to give more perspective is, for anybody who's seen the movie Indiana Jones and the Kingdom of the Crystal Skull, there's actually a sled track scene in there. So Indy and another, I think one of the bad guys, they actually ride a rocket sled. They actually use a jet engine on there, but it's the same principle. It's not that far off in one of the scenes in the movie. So if you haven't seen that, or if you have seen that, go back and take a look at that, and you'll get a better perspective on actually what what a SLED test would do. So as a test capabilities integration engineer at AEDC XPROL, which is that test capabilities integration branch, I've been fortunate to work with and lead teams to achieve long-term upgrades and in capabilities and infrastructure. I've got a few major current projects at the landing gear test facility and the Holloman track to share here. So to start here at the landing gear facility there, I am the lead for the Joint Multipurpose Dynamometer effort, or JMPD. This is an effort that proposes to develop a new testing machine to support the whole spectrum of aircraft landing gear, to include wheel and brake testing, tire performance, landing gear system testing, really a world unique capability that's going to be able to do a lot of the mission set within one facility, within one machine within our facility. With that fully adequate landing gear testing, the government and commercial wheel and tire manufacturers project to use this facility to save millions upon millions of dollars in avoided failures in the future. Currently, we don't have capabilities up to maybe what they need to be, so we want to really push the limits of that here, and we're working with a great team to really get this project funded and developed. We've been working with this recently, and in the near future, we're hoping for really good things on this project. And then over at the track, so I'm the lead for a couple of projects over there. First, I'm the project director for the Joint Economical Sled Track Rocket, or JESTER project. That is a project mainly intending to augment and enhance the sled track rocket propulsion capabilities to propel articles down the track. It develops new rocket motors and sleds and really a full system for the next generation of sled track testing. Propulsion, it's necessary from a basic level to propel test articles down the track at whatever required velocity is needed for customers. And certain sources of existing propulsion have been diminishing. So Jester intends to enable continued dynamic sled testing long into the future, for the next several decades here. It's really going to be solid rocket motors, repeatable, storable, and on in an instant solid rocket motors that can get us up to speeds that we need and be in storage after many years. We used a lot of motors over the past, that have been built since the 50s, 60s, 70s, that, we're trying to bring you the new generation of sled track propulsion for. It's actually been a really fun project with a lot of collaboration over the last couple of years within the community. And we've worked a lot with the other DoD tracks. So there's one at China Lake and one at Eglin Air Force Base in Florida, a couple other tracks around the country, but those are the other DoD ones along with Holloman. And, we can, I guess, call ourselves true rocket scientists as we go through this. Second, I am also the lead for the Holloman rail modernization effort. That's a major investment effort proposing to completely rebuild the entire 10 miles of the Holloman track and modernize its capabilities. Most of the track was built from the 1950s to the 1970s. So, after 50, 60, 70 years for the vast majority of that infrastructure, it's in need of some tender loving care, as you might imagine. It's a large MILCON project, and we haven't really, as a squadron level unit or even through AEDC, we haven't really done a massive infrastructure project like this in a very long time. So we're in the planning stages of this here, currently working towards funding for that. We have kind of funding in place, we think, but we're working with a large group of individuals all the way up to the Pentagon and the OSD level here to get these projects funded. All of these projects that I've mentioned offer a lot of variety in day-to-day work, and I'm fortunate to be able to work with some really good teams with diverse skill sets, all the way from the highly technical up to the financial and programmatic levels, and I kind of fit somewhere in the middle of that. Okay, and then finally, the SMART program and the impact that I've had from me here. So, it's played a huge part in getting me to where I am today. When I applied for SMART, actually, I wasn't sure where I wanted to work and, kind of rolled the dice, putting a few facilities and installation preferences in my application. Somehow, I made it made it through the process. And when I got my first call on it, it was from the landing gear test facility. And even though I'm from the Midwest, I'm from Wisconsin, I had never even heard of Wright-Patterson Air Force Base. I didn't come from a military family or anything like that, but I gladly accepted, and the rest really for me is history. The SMART program picked me up for my last year of undergrad, and so it was just the 1 year over there. Now, I guess 7 years into my career, my Air Force career, I'm still going strong and enjoying what I do. Planning for many more years into the future onto this. Into this job, and then future Air Force jobs, or at least future DoD jobs. Just as I'm sure all SMART scholars can appreciate, and has been mentioned already today, after acceptance, I was lucky to not have to worry much more about my financial health and where I want to get a job after school. It was all kind of set up, within a year. For me, it was a year out, so that helped a lot. I could focus on academics, and I did very well in my last year, prepared me for my last real job, and moving not too far, just across the Midwest, but the SMART program really helped give some clarity for my last year of undergrad and what I was going to do, where a lot of my classmates were trying to figure out what they were going to do. And so since that acceptance, I've been fortunate to have worked for 3 great organizations in Ohio and New Mexico at Wright-Pat and at Holloman. Doing a lot of the stuff I previously mentioned here, managing major projects, seeing things go faster than most people can imagine. Again, recommend you take a look at the videos for that. That's always a crowd pleaser, just on YouTube. Working with a lot of great people, to include, some Pentagon trips as well up there. So I've had a lot of good exposure in my early career thus far. And certainly can't move on without acknowledging the mentors that have helped me grow throughout this project here, or this whole process, and a lot of these different projects, I should say. Even able to pick up a master's in space engineering along the way to, become, at least on paper, an actual rocket scientist. Overall, it's been a great 7 years, and I've got SMART to thank for all these getting all these wheels in motion from the beginning. So thanks a lot, and we'll, if time permits, I'll be happy to take any questions. Thanks.
Hi, Brian. Thank you so much for your talk. Again, if there are any questions, you can feel free to pop them either in the chat or in the Whova platform, whatever is easiest for you. But let's go ahead and move on to the next speaker. So the next presenter is Adam Siren. He is at the Naval Air Warfare Center Aircraft Division in Lakehurst. And his project is mastering the way of SMART. So Adam, whenever you're ready, go ahead.
Thanks, Monica. Thank you for the introduction. First off, I'd like to acknowledge and thank everyone for attending and the administrators for hosting, and then also our fellow scholars for sharing their research and different work environments. It's really kind of fascinating to see how everybody else is dealing. And so I took a different approach to my presentation. I really kind of wanted to focus on how my applied engineering and research have kind of come together and formed a crossroads. So I'll share my presentation here. Sorry about that. I apologize, Monica, because it doesn't directly talk about my my project. So, but just generally, I just wanted to give it kind of a vague title, but also, kind of draw you in because everybody's seen the For Dummies series. I certainly tend to go after those books. So Mastering the Way of SMART for Dummies, and it's just kind of a play on words. So it's me being cheeky. My name is Adam Siren. I currently work at NAWCAD Lakehurst, so Naval Air Warfare Center Aircraft Division in sunny Lakehurst, New Jersey, about 25 minutes from the Jersey shore. Yes, that one. And my cohort year was 2015. And so I received the SMART scholarship to attend Worcester Polytechnic Institute in Worcester, Massachusetts. And that happened from 2014 to 2018. And after I began my career in phase 3, in phase 2 of my SMART scholarship, I also ended up going for a master's in mechanical engineering through Drexel University, and that was funded through Section 219 NICE funding at our university, at our organization, because we offer various degrees through that. I want to give a quick shout out to Amanda Turner for her guidance and patience as my presentation was processed through the Lakehurst PAO, and that took a while. So thank you, Amanda. I really appreciate your patience and everything. So next slide, I'm just going to talk about my organization and what we do at Naval Air Warfare Center Aircraft Division in Lakehurst. So Lakehurst, New Jersey, actually, fun fact, is the airship capital of the world. And this basically started back in the good old early 1900s when we were still dealing with the Hindenburg. And actually, we have a hangar that still exists on base that was built specifically for the Hindenburg, where it would actually be inside of it and it would have 18 inches of clearance on each side. So it's kind of cool to still see those history facts. But kind of moving to today in the modern approach. So we are the world leader in support equipment and aircraft launch and recovery equipment. And basically, these are all systems that support aircraft that launch and are recovered on aircraft carriers, both legacy and the new Ford series that's been released in the past couple of years. So our unique mission is to assure fixed and vertical wing aircraft operate safely and effectively from aircraft carriers, air-capable ships, and expeditionary airfields worldwide. So we not only deal with carriers, we also deal with some destroyers. We also deal with other arresting systems and different catapults and things of that nature, and the various pieces of support equipment and different advanced technologies that we're trying to incorporate into the actual fleet as we move forward with our technology, and as technology develops, and as we receive various other high energy aircraft and new developing technologies on these actual aircraft. So next slide. So this is just kind of a background. This is a lot. I'll kind of go through it. This is a background of my experience through the various internship programs, and not just in SMART, but also before and then after, and then my experiences through phase 2 and et cetera. So pretty much I've always been interested in STEM and engineering and mathematics, and this was specifically sparked through my competitive robotics team in high school. And essentially, there was a DoD employee who was one of our mentors who basically became my dedicated mentor. He really took a liking to my curiosity and my passion for science and technology. And he kind of sparked my interest in looking into what programs were out there, even while I was still in high school. So pre-phase 1 in 2013 and 2014, I applied for the Science and Engineering Apprenticeship Program as a junior in high school. And through junior and senior year of high school, through the Office of Naval Research, I actually got to work at Lakehurst in the Advanced Technologies Group, and actually where I would end up in the long term through the Mark 7 arresting gear group. And we'll talk about what Mark 7 arresting gear is. And then in the next summer, once I became a college freshman, I was invited to participate in the Naval Research Enterprise Internship Program. So that's NRIP, and that's also through the Office of Naval Research. And this position was in the All-Rate Instrumentation and Test Department, which sounds very vague, but basically I was working on testing the Advanced Arresting Gear System, which is on the Ford class carriers as a new and upcoming arresting gear. So this led to my eventual application to SMART, and through the National Defense Education Program, I was awarded that, and I'm extremely grateful for that. And so with my internships there, I worked in the fixed wing support equipment branch, specifically working on C-130s, which are basically large cargo vessels. And then I came back to Mark 7 arresting gear. However, this time I looked into the research and development of our performance systems and analyzing our actual dynamics in the engine, and kind of understanding what is happening and how we can improve our engine as we adapt to new aircraft. So this leads me to my current position, which is I'm an in-service engineer for Mark 7 arresting gear. And so basically in my daily position, I help service the fleet and essentially anything that they need, any contractors that we deal with. We help them figure out engineering questions or if there are incidents that happen on the ship, because the system has had many developments and many iterations over the years. We basically lead engineering investigations and potentially engineering change proposals to continuously look at how the Mark 7 is faring against this updated technology. And we want to ensure optimal performance, operational safety, and system availability, because the fleet needs the system to operate. And then in addition to that, so one of the cool things we got to do here at Lakehurst was the Innovation Challenge, which is, I'll talk more about this, but basically it's a program that allows newer employees to basically pitch an idea and run with an innovative idea to try to basically better the fleet and give them, address a technology gap that essentially is a big part of what they're doing out there. So I led this team called the Cross-Deck Pendant Wire Rope Analysis Tool. And we were consisting of 4 multidisciplinary engineers and computer scientists. And we actually ended up developing a wire rope prototype, an inspection tool for wire ropes. And basically we developed it during the pandemic, and it was a great experience to actually be able to figure out how to solve a complex problem like this. So in the next slide, essentially the Mark 7 arresting gear is on all legacy aircraft carriers. And so those are the big vessels that we send out to sea. And essentially the idea behind it is it's a big block and tackle system, which basically consists of a wire and then a hydropneumatic system to dissipate all of the energy that is created when an aircraft, as you can see on the right, actually lands on deck and embraces that cable, and the tailhook engages to the cross-deck pendant, or CDP. And essentially in this arrestment, there's something like 50 million foot-pounds of energy that need to be dissipated in a really short run out to make sure that the aircraft remains safe on the aircraft carrier deck and doesn't fall off the edge or anything like that. So the primary objective with our system is to preserve 99.999, and we really mean 99.999 because percent reliability with the continuous development of basically of advanced high energy aircraft, because of the fact that aircraft are expensive. More importantly, life on deck in terms of like sailors or the pilot or anybody involved, that's an incredible thing that we try to maintain, and we make sure that we maintain that reliability. So engineering, our in-service engineering impacts the Department of Defense by using data-driven analysis to challenge assumptions and maintain a fleet focus while ultimately serving the warfighter. So that's a lot to say. Basically, we take input from the fleet and then move towards making changes and different things that they see as areas where we could improve upon. And basically, we incorporate those changes through the engineering proposals or engineering investigations. And essentially, we're serving them because at the end of the day, the fleet is our customer as much as we want to be innovative. And we go to them to figure out what's the next big thing that they would like us to work through. So that leads me into the next part of my work at Lakehurst, which was with the Innovation Challenge. So just to give you a broad background, the Innovation Challenge is a 6-month rotational opportunity for developmental junior employees at different NAWCAD sites. So there's NAWCAD Lakehurst, and then there's our home organization, which is NAWCAD in Pax River in Maryland. And essentially, these teams are comprised of 4 to 6 members with no more than 5 years of experience at either or both of the NAWCAD sites. And so basically the team is composed to tailor to the concept of the actual prototype, and it could be anything. It could be something that's used as support equipment or something that's used in the all-right area. So basically we needed to come up with a proposal, draft budget, plan of action, milestone chart, and then we were given a $25,000 budget and a $5,000 travel budget to execute the program in our 6 months and provide an actual prototype. So something that I saw that was important to us is actually going back to the 99.99% reliability. And one of the big areas that we run into issues with are the cross-deck pendants, which I referred to earlier. And those are the wires that the tailhook engages with when you're talking about your F-35s, your F-18s. And essentially, the cross-deck pendant wire rope analysis tool is a system used to inspect the in-service arresting gear CDPs using a machine learning classifier to acquire data of the cable profile and determine if deformities exist. Now, so one of the big issues that we run into currently is there is no technologically assisted method for inspections to occur on deck. And the problem is that these inspections of these cables, as they degrade over time, because they're taking such a big impact from the aircraft tailhooks and things like that, the maintainers are trying to work through as many cycles as possible, getting the engine back up to availability and making sure that we're ready to go. But this is one of the major points and one of the biggest cost drivers in the ALRE world that we're dealing with. So basically, if we could have a way to find these deformities and make sure we understand how these cables are breaking and how they may degrade over time, that potentially could turn into a cost savings and additionally improve the overall quality of our maintenance procedures and essentially, boost that reliability up even more. So the current requirements that we have they're insufficient, and there's difficulty identifying the actual broken wires. So, oops, sorry about that. So basically what we set out to do with our team in the 6 months was to develop a functional prototype deliverable. And so throughout the 6 months, which actually happened to be during March 2020 to September 2020, very convenient timing. Basically, this was during the COVID-19 pandemic, but we developed a prototype that was fully working and briefed SES leadership and other distinguished professionals at both NAWCAD Lakehurst and NAWCAD Pax River. And then this basically led us on to multiple follow-on efforts, and they were funded through Naval Innovation Science and Engineering funding in fiscal year 21. And basically they were innovation sprints and mentoring pulses, which are two different efforts that you can do to forward some research along with not a lot of money, but definitely with a ton of resources at your disposal, which is very cool. So that was just kind of it was a lot about the work that I do, but I really wanted to focus on the other impacts of SMART with my experiences. So the SMART Scholarship has provided me financial support, like many of my colleagues have said. It really allowed me to focus on academics. And it also just allowed me to breathe a sigh of relief to not have to worry about various issues with figuring out where next semester's tuition is coming from. So that was extremely helpful. And additionally, it allowed me to attend Worcester Polytechnic Institute, which has an amazing robotics program. And that really, really was something big that was important to me. Additionally, internships with real world experience, and that experience is invaluable. You're able to apply that during your classroom projects and just in general with the classroom. It also gave me a step up with understanding how NAWCAD works and how the organization actually functions. And this led to networking, obviously, and obviously getting more visibility with high-ranking engineers and leadership throughout the actual organization. And this has actually led to me, I will be transitioning as of October at the beginning of the new fiscal year. I'll be transitioning to the team lead for our track site engineers. Basically, we'll be working, I'll be working as a test site engineer, maintaining the multiple jet car track sites that we have here at NAWCAD Lakehurst. So it's kind of interesting to see how the different areas that I've worked through are kind of coming back full circle, and people are embracing, various engineers are embracing having me back and working with them. And so then that leads to mentorship opportunities. And basically those folks that have, mentored me over the years, I kind of see as there's a need to pay that back in a sense and pay it forward. So this has also led me to seek mentoring, workforce development and volunteering opportunities in the organization, and also spanning from the organization to other STEM educational outreach events. So for example, I work closely with our workforce operation office and our science, technology, and engineering and mathematics educational outreach program, specifically with FIRST Robotics. I tend to volunteer at these events a lot to kind of give back to that organization that gave me so much and, lit that initial spark to move forward with engineering. And also, I also reach out to local K through 12 STEM educational events with our local middle schools and high schools, and the workforce operations office is very supportive because they've seen the impact that SMART and other programs alike have had. So to be able to pay that back is amazing. And also just being able to take action within our diversity action teams internal to NOCAD. So as a member of the LGBTQ community, I also am a big part of the LGBTQ+A action team. I work with the Women's Initiative Network and also the Individuals with Disabilities team. So, Individuals with Disabilities Action Team. So it's just amazing that there are so many opportunities available from being involved with SMART, and just being able to work with an applied research aspect, but also applied engineering, and potentially work through building a really long and fruitful career. So that concludes my presentation. I know that was quite a bit, but I would yield any questions, and thank you very much. Appreciate it.
Adam, thank you much for your presentation, and congratulations on your promotion. That's awesome.
Thank you.
Again, I just want to remind everybody, in case you do have any questions, you can pop them either in the chat or in the Whova app, whatever is easiest for everybody. And I think we can go ahead and move on to our next presenter. So our next presenter is Morgan Barron. Morgan is at the U.S. Army DevCom Ground Vehicle Systems Center. And their project title is The Role of Modeling and Simulation in the Electrification of Military Vehicles. So Morgan, whenever you're ready, you can go ahead and get started.
Perfect. Thank you for the introduction. Good afternoon. My name is Morgan Barron. I'm a Phase 2 SMART Scholar. I'm a cohort of 2018 at the Ground Vehicle Systems Center, or GVSC, in Warren, Michigan. I graduated from the University of Utah in 2020 with a bachelor's degree in mechanical engineering. Today, my presentation will focus on the role of modeling and simulation in the electrification of military vehicles. GVSC is a part of DevCom, the U.S. Army's Combat Capabilities and Development Command. Our mission is to develop, integrate, demonstrate, and sustain ground vehicle system capabilities in support of Army modernization priorities and improve fleet readiness. Simplified, our mission is to support warfighters through innovation. So what does this look like? Last April, Defense Secretary Lloyd Austin identified climate change as an existential threat to global safety. Following Secretary Austin's lead, the Army released its climate change strategy, outlining how the Army will achieve a 50% reduction in net greenhouse gas emissions by 2030 compared to 2005 levels, and obtain net zero greenhouse emissions by 2050. In support of this goal, the Army will field purpose-built hybrid drive tactical vehicles by 2035 and fully electric tactical vehicles by 2050. The benefits of electrifying military vehicles reach beyond sustainability. Hybrid or fully electric vehicles also have tactical advantages over conventional vehicles, including faster acceleration, increased fuel efficiency, and silent operation capabilities. M&S is a critical tool for delivering these fully electric or hybrid military tactical vehicles. It gives engineers and researchers a way to benchmark vehicle capabilities, isolate shortcomings in existing designs and emerging technologies, and improve vehicle design, all before physical development begins, which will, in the long term, reduce the risk, cost, and time required to develop these vehicles. As a member of GVSC's Analytics Directorate, the Army's premier organization for modeling and simulation technical services, I support Army electrification goals by modeling hybrid and fully electric concepts. As a result of the results of the general model that I use to evaluate these concepts include vehicle speed on grade, time to speed, fuel economy, and con-op evaluation. These models can generate speed on grade and time to speed results for 4 different cases: when the vehicle is operating with battery power only, with the engine power only, with both, and with some engine power being used to charge the battery. When the battery is providing power to the system, the model can report how vehicle actions such as time accelerating or time at top speed impacts the battery's overall state of charge. When the battery is being recharged, the model reports how long it will take until the battery is fully charged. The fuel economy and con-op evaluation results are slightly different from each other, but of the same species, let's say. Typically, a fuel economy analysis is performed at 30 miles per hour over flat pavement, while the con-op evaluation is performed at different speeds over different terrains as specified in the vehicle's concept of operation. Most of the concepts are in the preliminary design stages when I begin creating a model to evaluate them. There are often gaps in the available information, so it's important for these models to be as flexible as possible, as the M&S process will likely be iterative. I take small actions to make sure that my model can be adapted or built out with additional information when it becomes available. This can look like creating and maintaining a data script separate from the model to ensure that no parameter values are hard-coded into the model, creating local functions for common actions or calculations within the model, or thoroughly commenting the code so it's clear what the code is doing when that section is revisited. I have adapted these more general models to verify specific vehicle performance claims made by contractors in program proposals. For instance, the Electric Light Reconnaissance Vehicle, or ELRV, proposal evaluation model evaluates the proposed vehicle's expected speed on grade, time to speed, expected performance over the ELRV's con-op, and total energy use over primary, secondary, and cross-country terrain. These results will provide the ELRV selection committee with a quantitative and impartial measure to evaluate the proposals. Wheeled vehicles like the ELRV are not the only vehicles that the Army uses. 63% of the tactical vehicles that the Army procured in 2020 were tracked, and the Army is interested in electrifying these vehicles as well. Electrifying tracked vehicles has an additional complication as these vehicles use differential steering, also known as skid steering. Differential steering turns a vehicle by applying more drive torque to the outboard sprocket than to the inboard sprocket. As tracked vehicle components often experience peak power demands during turning events, a turning model, in conjunction with a more general automotive performance model, is required. This model calculates the power required at each sprocket to complete a turn at the defined speed and acceleration, and then determines the power required to pass through each component. While this turning model is currently only being used to size and evaluate components, in the future, my team wants to integrate this turning model into our tracked fuel economy analyses, as our current models only assume straight line driving, providing an inaccurately optimistic estimate of the vehicle's potential fuel use. The SMART program made me the engineer that I am today. As a student, the SMART program covered my tuition and provided a generous living stipend, which allowed me to afford school without having to work. With this financial support, I was able to focus on my degree, participate in engineering outreach activities through the Society of Women Engineers, and join my university's paper to improve my writing abilities. As an intern, my team included me in meaningful projects that I've continued to work on as a full-time employee. My university did not have automotive engineering courses, so my team recommended webinars for me to attend and loaned me textbooks to read even after I returned to school. When I officially joined GVSC in early 2021, during maximum teleworking, I was confident in team workflows, familiar with current projects, and connected to my teammates, which made onboarding and collaborating remotely much easier. Now, as a young professional, the SMART program still provides me with the support that I need to grow as an engineer. I have 2 incredible mentors who encourage me to participate in relevant engineering professional developments and provide constructive feedback. Working as a research engineer on several different projects has given me an opportunity to discover what engineering projects interest me. As I plan to return to school to seek a graduate degree, this insight into my field has been invaluable. Thank you for your time and attention today. I'll yield back for questions.
Morgan, thank you. That was really awesome and really informative. And again, I just want to say, if you do have any questions, you can certainly, again, put them in the chat or in the Whova app. And then we can go ahead and actually move on to our final presenter for this afternoon session. So the final presenter for the afternoon is Catherine Pfeiffer Parks. And Catherine is at Naval Surface Warfare Center Crane Division. And Catherine's project title is SMART S&T. So I guess whenever you're ready, thank you for Catherine, you can start sharing whenever you are ready.
Good afternoon.
Catherine, you appear to have cut out. Are you there?
Hello.
Okay, yep, I can hear you. Oh, and now we can see your slides. Excellent.
All right, so good afternoon, everyone. My name is Katie Parks, and I work at Naval Surface Warfare Center Crane Division located in Southern Indiana. I graduated with a combined bachelor's and master's degree in electrical engineering from Indiana University, Purdue University, Indianapolis, or IUPUI. And so today I'm going to talk about some of the things I've been lucky to participate in while being a SMART Scholar. I am a 2018 SMART Scholar cohort in Phase 2. So to start out, so what is NSWC Crane and what do we do? So the mission of Crane is to provide acquisition engineering and service engineering and lifetime support for sensors, electronics, electronic warfare, and special warfare weapons. We currently have 3 areas of focus, which include strategic missions, expeditionary warfare, and electronic warfare. And I work in the electronic warfare department. And so what we do at Crane is we're a national leader in electronic warfare that provides life cycle support. We also are national leaders in special operations sensors and weapons for expeditionary warfare. So you can see in the bottom left-hand corner, or I guess on the bottom right-hand corner if you're looking at the screen, is a picture of base. We are the only Navy base that is not located on a large body of water. We do have a lake, though, that we're able to utilize for some testing, and then other local test ranges. So some of the work that I've been doing while I've been at NSWC Crane. So I work within NSWC Crane's electromagnetic warfare S&T division. I am involved with rapid S&T research, prototype, and development. This includes Loki payload development and then direction of arrival research, where I specifically focused on the direction of arrival by signal elimination algorithm. So some of the things that I do in the Loki payloads group specifically is I am the Valkyrie lead. We have 3 main payloads. We have Mystique, Valkyrie, and SEOP. Mystique is an acronym that stands for Miniaturized Expendable Signature Tethered IQ, and it is a small, low-cost electronic warfare payload. Valkyrie is not an acronym. It is just a smart EW payload. And then we have Spectrum Eye of Providence, or SEOP, which is just a spectrum monitoring payload that we use. So kind of within the Loki division, what we have to do is we have to understand the radio frequency spectrum and how to use it to create new and unique effects within the spectrum. We also have to do rapid prototyping and testing. And then on the other side of things, I am a part of the DOA algorithm research. And so what I did was I researched and simulated the algorithms in MATLAB. And so this included reading journal papers and understanding the math behind the different papers and then implementing those in MATLAB. And then I also had to understand the efficiency of each of the algorithms if it provided accurate responses. And then I was able to provide that feedback back to our project manager. So on the right-hand side, you can see the spectrum monitoring trailer on the outside and on the inside. And so I've been able to participate with our spectrum monitoring team at Crane. And so what we do is we take this trailer to different test events and we're able to watch the electromagnetic spectrum. And so what this does is it provides awareness as to what is currently playing on the spectrum. And we also make sure that people, when they're testing their systems, rather than it being in a lab environment and when they're out in public, they might not realize some of the spurious harmonics or things that they're having. So we make sure that everybody's testing in the right bands. And it's been a really great learning opportunity for me. And then you can see on the inside, we have a bunch of monitors and stuff that we're constantly watching for both learning and for just making sure that everyone's transmitting where they're supposed to. So to dive a little bit deeper into Loki, so Loki, if you're a Marvel fan, is the god of mischief. And so that's exactly what we're doing, is we're trying to fool the adversary to be in the right place at the wrong time or the wrong place at the right time. And this can be done by delaying, misleading, and distracting. So we utilize commercial off-the-shelf materials to keep costs low and updates super easy. And so, like I said earlier, we do have 3 payloads in the Loki family. Those include Mystique, SEOP, and Valkyrie. Mystique and Valkyrie are our EW payloads, and SEOP is what we're using for spectrum monitoring. You can see one of our SEOP applications for spectrum monitoring in the picture at the top of the screen. And so that was one of the first iterations. What we did is when we were at these test events monitoring the spectrum, our spectrum manager actually requested a portable device that he could carry around with him to determine where signals were, if they were exceeding certain thresholds. So what we did is we took that information and his feedback, and we were able to then create this graphical user interface that is viewable by the user and portable on a small screen and small computer. And so we have been able to do many iterations of that. And that's where the rapid development comes in, is we had an idea, we prototyped it, made one iteration, and then we took it out and tested it at another test event. And then we were given feedback from the operator or the spectrum manager. And then we were able to take it back to lab, make some more edits, and then continuously update it for perfection for what he needed. And so we've gone through many iterations of the graphical user interface in that case. So my role in the Loki payloads team for the Mystique payload, I'm just a test support engineer. And so I will take this payload out to test events. I will set it up, I'll run it, make sure that it's doing what it's supposed to be doing, and then help provide feedback to the main programmer for the Mystique payload. And then for Valkyrie, I'm the project lead. And then for SEOP, I'm the programmer and test support engineer. So as a test support engineer, we attend those test events, we help set up equipment, and I test the payloads. We have to write post-test reports and come up with ways to improve that usability and have an operator hands-on understanding of the technology. And then as the Valkyrie lead, I develop a strategic plan and a roadmap for Valkyrie so that we have years of continuous improvement. I help create presentations, white papers, and documentation to help get resources and understanding of what it is we're doing with that specific payload. And then I also train other engineers and scientists on how to operate the payloads so that they could become aware of our capabilities. And then as a programmer, I create a graphical user interface for different applications, and then I get operator feedback on the usability of those programs for that constant iteration. And the SEOP application for spectrum monitoring was actually my first program that I did from start to finish and have continued iterations on it from this day forward. We also have a YouTube video that you can search. It's NSWC Crane Capabilities, Loki, where you can learn more about our Loki projects. And then on the bottom, you can see the payload integration at test events, and we integrate into pretty much anything. We're always very flexible. So then some of the direction of arrival algorithms that I've been working on. specifically the direction of arrival by signal elimination or DOSE algorithm. So this was brought to me to research and try to simulate, because when you have different signals arriving from different angles, we don't know where it's coming from. And so you try to pull those apart from each other and identify the azimuth and elevation of where those signals are coming from so that you can locate transmitters. So the desired signal arrives from the different locations, and you have multi-path propagation that is also added. And then high frequency ionospheric propagation causes scattering, so that can also cause problems with identifying the direction of arrival. And then there's also multipath. And so this algorithm tries to solve those problems. So how it works is you have a uniform linear array, which is just a line of receivers as seen in the bottom of the screen. And so the first step is you're going to receive the signal data into that uniform linear array, and you're going to plot the spatial periodogram. And then after you find the spatial periodogram, you find the peak. So if you look at step 1 and 2 at the picture up in the top right-hand corner, you can see the spatial periodogram and the 2 peaks that it identified. We're going to take the largest peak. So the largest peak is negative 2020. So that's azimuth elevation. And then from that peak, we're going to set the threshold. The threshold is a fraction of that amplitude of the peak. Once you set your threshold, you're going to null the signal that was already found. So the signal that was found at negative 2020. And then you can see in step 4 in the image in the middle that signal was nulled, and you're left one peak. And so that next peak was found using the DOSE algorithm. And so you can take that next peak that was found at 40 degrees, 45 degrees, so azimuth elevation, and then you can write those down. So now you have 2 peaks, 2 signals that you have identified. And then what you're going to do for step 6 is you're going to continue steps 4 and 5. So to null the signal you found, and then again, do the DOSE algorithm until the threshold exceeds the identified peak. So once your amplitude becomes lower or smaller than your threshold, then you're going to terminate the program. So as you can see in this example on screen, that there were 2 signals that were identified, one with a direction of arrival at negative 2020, and then another with direction of arrival at 40 degrees, 45 degrees. And so from this research, we were able to find that this algorithm does very well, except when the signals come from very, very close degrees of separation. So if there's only 5 or 10 degrees of separation between directions of arrival, then the signals sometimes might merge, and you might not be able to identify the 2 different signals that are actually coming through. So this was good for me to be able to share with them so that they could determine if this was an algorithm that they wanted to continue research in. And so finally, how has SMART impacted me? SMART has positively impacted my life in multiple ways. I have been able to focus on my academics, and I was able to focus on joining clubs and extracurricular activities during school. I finished school debt-free, which was a huge goal of mine, and I was able to actually pursue my master's degree, which I had no intention of originally being able to pursue due to financial reasons. And so once I got the SMART scholarship, it allowed me to pursue that further education, which was able to really help my career when I started at Crane. And so I also have a career that I really enjoy. It's meaningful to me, the work that we do at Crane, and I'm always enthusiastic to go to work every single day. And so my internships prepared me because I was able to network with multiple people across space. I was exposed to cutting edge technology and new trends. I was mentored by many different people, both technical subject matter experts and business development experts. I had hands-on experiences and training. I built knowledge and connections so that I could easily transition from being a student to being a full-time employee. Since I knew almost all of my coworkers when I started, it made everything super simple and easy. And then some just fun, cool opportunities I've had is I was able to ride on 2 small Navy vessels. You can see me in the back there in the bottom picture. I watched A-10s take off and land, which was super fun. And then I traveled to some really neat places within the U.S. I've been able to meet with some warfighters that our work directly impacts. And then was able to take a 2-week training called the Rapid Innovation Prototype Lab training, or RIPPLE. And during that training, I learned to weld, sew, 3D print, and machine. And as you can see, the hammer I fabricated in the RIPPLE lab can be seen smashing barriers and crippling debt. And I actually was able to have my hammer with me today. I keep it in my office. And so it's a good reminder of all of the opportunities that I've been able to have while I've been in the SMART program. So I appreciate all of you taking the time to listen to me today. And if you have any questions, I'd be happy to answer them. Thank you.
Katie, I believe we have 2 questions in the chat. We can go through them very quickly. One of them is from Dr. Kokenhauer. Have you been able to test your direction finding algorithms out in the field?
So I have not been able to test them out in the field. It was mainly the research I did for was mainly just to kind of get some simulation and get some ideas on if that was something that they would like to pursue further or research further.
We do have a request to see your hammer again, because that's really cool. That's awesome. And then we do have another question from Dr. Lejon, I believe. And she says, I may have missed it at the beginning of your talk. Are the systems currently in use or still in testing development?
So all of our are currently still in the rapid prototype and development stage. We are a low TRL group. So we're all S&T. So we kind of come up with the cool ideas, kind of rapidly prototype, test them, and then further on, if someone is interested in procuring them, then that's where we would pass that on to another group within Crane.
Okay, well, I think that wraps up the questions. I just want to thank Brian, Adam, Morgan, and you, Katie, for your time, and I will turn it back over to Dr. Kokenhauer.
Thanks, Monica. Another thing that I hope everyone picks up on when listening to the scholar talks here, beyond just the technical work that they're doing, nearly all of them have mentioned the value of the mentoring that they've received from folks within their DoD labs. And I think that's a really unique aspect of the SMART program, in addition to obviously the financial and the scholarship benefits, that ability to do internships during the summers while you're pursuing your degree and kind of getting involved with the folks that will eventually become your colleagues is really, really valuable. So I'm really happy to hear that so many of the scholars have had some positive experiences there. Okay, so that concludes our session for technical talks. If I could give a bit of traffic directions here for what we have coming up next, because we have a few concurrent sessions happening. So first, for those of you that are looking to hear a little bit more about the SMART program and all of the benefits and the application cycle, I would encourage you to hop off now and go over to the Smart 101 session. You can find that under sessions in the Whova app. That's about to get started any moment now. For our scholar speakers, at 2:30, we'll have our first speaker workshop. And then also at 2:30, for our sponsoring facilities and DoD mentors and supervisors, our first sponsoring facility workshop. And again, you can find those links under Whova in the agenda session. If you're having trouble accessing anything, again, please send an email to outreach@smartscholarship.org, and we can help get you to where you need to be. Okay, since we will not gather again as a full group until tomorrow, thank you all for joining us, and we hope you have a interesting and beneficial afternoon, and we'll see you back tomorrow morning. Thanks, everyone. Bye-bye.